Okay, an exponential function is any function of the form a times b to the x power. And there are some restrictions on a and b, but for the most part, what you need to know is that if the a and b are going to be constants, they represent constants, kind of like slope and y-intercept in an equation of a line. But the input variable is itself the exponent. That's why this is called an exponential equation. So if this b number is bigger than 1, like y equals 3 times 2 to the x, then you're starting with 3 and you're multiplying by 2 over and over and over. Multiplying by a number bigger than 1 will cause growth. As you multiply by higher and higher powers, the function will get bigger, and it would look like, well, that's probably not the best coordinate plane for that, but it would look like this. You take, and this point right here would be, for this function, if you multiply by 2 0 times, you have the 3 that you started with. 3 times 2 to the 0 power would be 3. And then 3 times, you'd have 1. That would be the 0.19, etc. No, not 19. Goodness gracious. 16. 3 times 2 to the first power, etc. Well, what if b is less than 1? Suppose we have the function y equals 1/2 to the x power. Okay, we could set up a table of values for this, just like we set up a table of values for the exponential growth function. 1/2, well, oops, if x equals 1, y would equal 1/2. If x equals 2, 1/2 times 1/2, 1/4. If x equals 3, 1/2 times 1/2 times 1/2 would be 1/8. So let's take a look at what that would look like. We have the point 1 1/2, 2 1/4, 3 1/8. What about if x equals 0? 1/2 to 0 power. Well, anything to 0 power is 1. How about the -1 power? So 0, 1. Notice as we go down the line, we're dividing by 2. As we come back up the table, we're multiplying by 2. So this will be -1, 2. 1/2 to the -1 power means you take the reciprocal of the 1/2. You have 2 to the first power. So -1, 2. And -2, 4. And -3, 8. -3, 8 will be too high. So this is going in the exact opposite direction as the exponential growth function. This is called exponential decay. If we take this and put a 3 in front of it, like y equals 3 times 1/2 to the x, well, that just means you're starting with 3. When x equals 0, y equals 3. When x equals 1, y would equal 3 times 1/2. So that would be 3/2. When x equals 2, y would equal 3/4. You multiply by 1/2 again. Multiply by half again, 3/8, and so forth. This is still going to have the same shape as the other graph, but instead of going through 0, 1, it'll go through 0, 3. 0, 3, 1, 3/2, 2, 3/4, 3, 3/8. Still gonna have the same general shape. -1 would be 3 times 1/2 to the -1 power. 1/2 to the -1 power is 2 to the first power. So 3 times 2 would be 6. So that would be up here. So still the same general shape. And this is what an exponential decay graph looks like. The higher x gets, the smaller y gets, the closer to 0 y gets. And that's an example. That's some basics of exponential decay. And it happens whenever the base of the exponent is less than 1. Because multiplying by a number less than 1 causes a decrease. The domain and range of an exponential decay function is going to be the same as the domain and range of an exponential growth function. The domain, x can be any number, so the domain will be all real numbers. And the range would still be y is greater than 0. So domain and range are the same for exponential growth and exponential decay.